Hello everyone, this week's NXT tutorial is going to cover line squaring for an NXT robot. In order to do line squaring on an NXT robot, you must outfit your robot with two light sensors on the front of the robot. One is going to control each wheel, so the right sensor controls the right wheel, left sensor controls the left wheel. So you want them to be directly ahead of your drive wheels. What I'm showing here has the sensors quite a distance in front of the drive wheels. Ideally you want the sensors to be just a little bit closer, if you can maybe even directly in front or next to the wheels. One additional note is that you're going to want your two sensors placed with a nice distance between them. If they're too close together, the line squaring really won't work very well. The wider the sensors are, the more precise your line squaring will be. So keep that in mind when you're designing a robot. So, the first thing that we need to do is measure the light values coming off of the light sensors that we have right here when we place them over different parts of the line. We're going to want to measure the reflected light value of the white line as well as the black line. And to do this, what we're going to do is scroll over to this view. We're going to go over to reflected light. Select one of our sensors that we have plugged in. I have two color sensors, light sensors, port 1 and port 2, so you can just choose one, and it's going to display the reflected light intensity. So what you're now going to do is put the sensor that's being measured over the white line and record the value, and then put it over the black line and then record that value. And of course, when it's over the black line, it's going to be a lower value because less light is reflected. Now, for the sake of this video, I'm going to say that the white value is 70% and the black value is 10%. But like I said, this is something that you're going to have to measure yourself, and it's going to vary based on your lighting conditions and what your mat is like. So now with these light values measured, I can show you how to build the line squaring program. We're now going to build this line squaring program, and as I go, I'm going to explain to you how it works. And I've got some helpful little notes up here. My white light was 70% and my black value was 10%, and like I said, these are measured, so that changes based on what you've measured. And right here I have my left motor is in port B, and sensor 1 is going to be controlling this motor, and my right motor is port C, and it's going to be controlled by the light sensor in port 2. Now it's important to have a light sensor assigned to each drive wheel. Now, moving on with actually building the program, we're first going to take a loop block out. What this first part is going to do is drive the robot forward until it sees the black and then stop. So you're starting just behind the line and you need to find the line. We're going to set this to our light sensor. It can be either one of your sensors. Mine are in port 1 and 2. So just choose one or the other. We're looking for the black, so we want it to be less than, and we want it to be our lower value. Now my black was measured at 10%, but I'm going to set this as less than 13 to give us a little bit of wiggle room. And this amount of wiggle room that you want to use is going to be, again, dependent on your circumstances, so you can judge based on your situation which is best. But I'm going to give about 3 degrees here. Next, what we're going to do is put a move block in here. We're going to have the robot move forward until it sees this black line. I prefer to have this at a low power level because it's going to be very precise at low power. So I'm going to set this at 35%. Again, adjust this based on whatever you'd like it to be. Of course, slower is going to be more precise but more time consuming. And we're also going to set this to unlimited. After that, we want to stop both of these motors. So with B and C selected, we just click stop and they break. Now we're going to move on to the actual line squaring part of the program. What I'm going to do is take out a loop block here. Now this loop block is optional. We're going to set this to count, and we're just going to leave it at 1 if we want it. And what this does is after the entire program has run once, it's going to repeat it one more time for extra accuracy. And this is optional because the program's plenty accurate without repeating it, but it just gives it another level of certainty when you repeat it. Of course, if you're crunched on time, you can always remove this loop block and the program will work perfectly fine. We're going to take yet another loop block and put that inside the previous one, except this one we're going to set to sensor, light sensor, and we're going to be centering our left wheel first. So port 1 is going to be controlling the left motor, so that's what we want to choose. We're looking for the white line, so we want it set to greater than, which it already is. And like I said, we're going to give 3 degrees of freedom here. So we want 67% because 70 was our measured value for the white line. After we have that set up, we're going to take a motor block for the left wheel. The left wheel was port B. We'll select that. We want to drive forward. We're driving forward off of the black line to the white. And of course we want low power. We're going to use 35% for all of the power in this. And instead of, well, we want this set to unlimited, because what we're going to have this do is drive the left motor forward until our color sensor sees, the light sensor sees the white, and then we're going to stop the motor, halt it where it is. We're going to take out a rotation sensor block for, this should be motor B. We're going to be controlling motor B the entire time until we're moving on to the next motor, which isn't for a while. Again, we're going to choose motor B. We're going to reset the motor encoder. So this new position that it's at is going to become the 0 position. Now that we're in the forward position, we're going to want the robot to drive in reverse to its reverse-most position where it sees the white line again. So what we're going to do is take out a motor block, and then I'm just going to copy and paste this because we're essentially doing the same thing but in the opposite direction. So after I've copied and pasted that, just reverse the direction. And now this is an important part right here. It may seem a little odd at first, but this is necessary. We're going to have that same motor driving in reverse at the same power, except what we're going to do is set this to some arbitrary duration. I'm going to set this to 40 degrees because that's what I've always used in competition. It varies based on your robot. The reason why we put this here is because the robot is already starting on a white line, and we want the robot to back up off the white line into the black a little bit before it starts looking for the white line again, because if we don't, it's going to be on the white line, then start looking for the white line, and already see the white line it's on, which we don't want it to do. So this kind of gives it a head start before it starts looking for the white line. Like I said, this is adjustable based on your robot and mostly affected by wheel size. The taller your wheels, the lower you want this value to be. And of course, play around with this for your best results. This is already all sorted out. We're going to do one last motor block here to turn off our motor B, and this is going to go after this loop block here. Setting motor B, turning it off. Now we've stopped again, and here comes the fun part where the math comes in. We're going to take out another rotation sensor block for motor B, and instead of resetting, we're going to read the degree value of the motor. We're going to take a math block, and we're going to set that to division. So divide by 2. The degree value that we've read is being divided by 2. And finally, take out one more motor block. We're going to be driving forward now, back in the forward direction. We're going to set the result of this math block as the duration for this motor block. And of course, 35% power. What we've done here now is we've taken the degree value that we've measured and divided it by 2 and given that to the motor as its duration, because essentially what we've done is we've moved the left wheel to its forwardmost position, stopped it, and then reset it, then moved it to its reversemost position. We've measured the distance between the forwardmost and the reversemost position. Now we have this distance. We'll divide it by 2, and we'll give that to the motor so it can return back to its center position. And now we've successfully centered the left wheel. However, we have to do this for the right wheel. And this is easy enough. It's basically the same exact process, except you want to change all of the motor ports to C and the sensor ports to 2. And since it's all the same stuff, I'm just going to copy and paste it in. And this is going to directly follow everything that we've just written. So here's the new programming strain. That just goes right there. And like I said, we just need to change everything, all of the motors to port C, and all of the sensors to port 2. And after we've done that, we've successfully created a line squaring program. So this is changed to C. This program is very monotonous and repetitive, but because of its monotony and repetitiveness, is repetitiveness a word? Anyway, because it's so repetitive, it's very precise and accurate. It always repeats itself to make sure it's correct. And you might want to fix this data wire because there's a possibility that it's going to become broken. So just redo that if any of the data wires get a little bit messed up when you copy and paste. So this is our completed line squaring program. Kind of long, but it's definitely worth the time that you spend during the match to square your robot to the line because it increases your robot's accuracy. Thanks for watching my tutorial this week. If you found it helpful, be sure to subscribe for more tutorials like this every week, and if you have an idea for a tutorial, be sure to submit it in the comments section below. Thank you, and I'll see you next time. Bye.